Okay, higher this week. We're going to be looking at straight line. Now a lot of this first couple of weeks will be revision from what you did in Nat 5. So here we've got our 2 points, x1, y1, x2, y2. We've made our right angle triangle. So what we're doing is we're looking at the gradient or the slope or the steepness of this line. So gradient, which we call M, coming from the French for montagne, is up over along or vertical over horizontal, or using the formula, which is more of what we're going to do, y2 minus y1 over x2 minus x1. Remember, your y is your vertical or your up, your x is your horizontal or your along. So looking at some ones here, for a horizontal line, your gradient is 0. For a vertical line, your gradient is undefined. If it slopes upwards from left to right, the gradient is positive. Downwards from left to right, the gradient is negative. And remember, parallel lines have the same gradient. So if it says two lines are parallel, they are going to have the same gradient. So looking at this one, what we've got here is we've got a theta and a theta using our F's and Z's. So we've got an F here. So these are both theta. In this case, what we're going to do is we're going to look, because we're looking at angles, and it's a right angle triangle, we're looking at SOHCAHTOA. So here, theta, this is O, this is A. O is y2 minus y1. A is x2 minus x1. So tan theta is y2 minus y1 over x2 minus x1, which is exactly the same as your gradient formula. So tan theta equals m. These three dots in this triangle formation mean therefore. So whenever you see these three dots, it means therefore. Theta is the angle between the line and the positive direction of the x-axis. That's the positive direction, i.e. that way. So looking at an example, e.g. A equals negative 6, 0, B is 4, 2. Find the angle between the line AB makes with the positive direction of the x-axis. So here we've taken our 2 points. We labelled them x1, y1, x2, y2. Our gradient formula, y2 minus y1 over x2 minus x1. We put our values in, so 2 minus 0 over 4 minus negative 6. So we get 2 over 10, which is 1/5. So our gradient m is 1/5. So tan theta we know equals m. So we put tan theta is equal to 1/5. And just like we did last week with the rat trig stuff, inverse tan of 1/5 gives us 11.309932, so 11.3 degrees. Distance formula. Again, you saw this last year. So here, x1, y1, x2, y2. The up is y2 minus y1. The along is x2 minus x1. So our distance, square root, x2 minus x1 squared plus y2 minus y1 squared. Basically, it's just Pythagoras. It's a right angle triangle, nothing to do with angles, so it's Pythagoras. So having a quick look at some of these. A is 2, 2, B is 5, 1, C is 3, 5. Prove triangle ABC is right angled and isosceles. So what we're going to do is we're going to work out the distance AB, the distance AC, and the distance BC. I would always do a wee doodle, a wee quick. You may notice there's no numbers, I've just kind of guessed. So I can see, it's not quite right angled in my drawing, but we can see that's looking like the right angle. So that's the one we've got to look at. So we bung it into our formula and we get root 10 for AB. We get root 10 for AC. And we get root 20, which we can simplify from 2 weeks ago to 2 root 5. So what we can see is these two distances are the same. So distance AB equals distance AC. Therefore, triangle ABC is isosceles. Two sides are equal, therefore it's isosceles. We don't have a third side equal, so it's not equilateral. So what we then do is we look at the longest side squared and the two shorter sides squared and added. And in this case, root 20 squared is 20. Root 10 squared plus root 10 squared is 10 add 10, which is 20. So c squared equals a squared plus b squared. So by the converse of Pythagoras, the triangle is right angled at A.